Hello class, welcome to the video for our first calculus investigation about limits. So basically we're just going to go through an example that's going to introduce the concept of a limit. And we will be considering the rational function given by the equation f of x equals x squared minus 2x minus 8 all over x minus 4. And so the first question is, what is the domain of f of x? And especially, this is calculus class, it goes without saying you're always going to have to explain your reasoning. So we can just take a little step back and remember from pre-calculus, what was it that the domain of the function represents? So the domain is talking about all of the values of x that are allowed to be plugged into the function. And so usually it's easier, instead of finding the entire domain, find out what is not a part of the domain. So basically, is there any value of x that I can't plug in? And things that we can't do usually are take the square root or fourth root or sixth root or any even root of a negative number, and also we cannot divide by 0. That's just kind of like the general things that you look for with equations like this. So there's no roots whatsoever, but we do have a denominator on the function here, x minus 4. So because x minus 4 can't be equal to 0, otherwise we would be dividing by 0, that lets us know that x cannot be equal to 4. And so then we can, this is kind of like our reasoning, okay? And then the answer of what the domain actually is would be the set of all x in the real numbers such that x doesn't equal 4. Okay, so I'm just going to put my answer in a little box to make it easier to read so that we know. Okay, so because, and we can go even further, if we plug in 4, we would divide by 0. Okay, so that's the domain of this function. And so I think in pre-calc you would just say, okay, we found the domain, we're happy, we're done. But then in this class we're going to go a little bit further and say, okay, so I can't plug in 4, but I can plug in any number that's as close to 4 as I want. And I wonder what happens to the y values of this function as the x values approach 4, get close to 4, but don't equal to 4. So that's kind of what we're going to look at next. And we're going to look at it in a variety of ways. So I often like to look at things numerically, graphically, and algebraically. So numerically would be often based on creating a table. So we're going to look at that in part B, which asks us to numerically investigate the behavior of f of x near x equals 4 by completing the following table. So as you guys know, you're required to have a graphing calculator in this course, and this is an example of when you would use it, not necessarily to do the graphing part right now, but definitely we want to use a calculator to compute these values. Okay, so for the first one, this is saying take 3.8 and plug it in for x. Let me push this so that we can see the equation. So we're going to be doing 3.8 squared minus 2 times 3.8 minus 8 all over 3.8 minus 4. Okay, so just to make sure you know where that is coming from, I'm taking 3.8 and plugging it in everywhere that I see the x in the equation, okay, in those 3 places. And I'm going to plug that in on my calculator, and you should do the same thing. Okay, and you'll see how many parentheses I wrote. That's how many parentheses I need to make sure that I get the correct answer on my calculator. And when I do this on my calculator, what comes out is approximately 5.8. So it's okay to round because this is just a numerical approximation. So when I plug in x equals 3.8, I get out y equals 5.8. So we want to do the same thing for all the values in order to find a pattern. And so if I plug in 3.9, I get 5.9. If I plug in 3.99, I get 5.99. Okay, so 3.99 is very close to 4 and smaller than 4. So then you might be like, okay, well, what if I plug in numbers that are close to 4 and a little bit bigger than 4? So if I plug in the next three numbers, I get 6.01, 6.1, and 6.2. Okay, so based on this table, what do you think happens to f of x as x gets closer and closer to 4? Okay, so again, we know that x can't equal 4. It's not in the domain, but we want to know what happens to y as x gets closer and closer to 4. And it seems like the numbers in this table from either direction are getting closer and closer to 6, right? 5.99 and 6.01 are both very close to 6. So I would probably guess that as x gets closer to 4, then I think that f of x gets closer to 6 based upon the values in the table. Okay, so that's like one way to do this. And then, like I said, we'll also always consider different perspectives when we can. We can think about this graphically as well. So like now we're going to plot f of x in Wolfram Alpha or on Desmos or on your graphing calculator. So sometimes it's easier for me, like on the computer, I could use Desmos or Wolfram Alpha, but if you have a graphing calculator, certainly suggest that you do that. So we're just going to take this equation here for f of x and enter it in a graphing calculator. So let me just use Desmos. Okay. If you're not familiar with Desmos, it's a nice online graphing calculator that's free. So we're going to graph x squared minus 2x minus 8 over x minus 4. Wow, look at that graph. It's quite interesting. Okay, and remember, guys, what we're interested in, I'm going to move the graph over a little bit because what we're interested in is actually what happens near x equals 4. Okay, so I'm going to take this and then copy it onto my investigation. Okay, so what I was seeing in that graph is the following thing. And in this class, I'm telling you right now, it's always very important to use a scale on your axis. Okay, so I'm just going to label them by ones. Okay, but you can label them differently. As long as you label them clearly, then it's fine. Okay, so it was kind of like starting here. It looked like it was going up like this and down like that, okay? And based on this graph, it did seem that when x approached 4, y approached 6, okay? So we can ask the question, does this graph support our conclusions? And it does, because as x approaches 4, y approaches 6. Now, are you interested in the fact that this complicated equation had a graph that's a straight line? And maybe, does that seem right? We should look into this a little bit more, okay? So this is like the discussion. Does the graph drawn support your conclusions in part A about the domain of f why is this graph linear? Let's sketch a more accurate graph below. So here's where we need to take everything into consideration. We also have to note that technology has limitations. Not every graph is going to be correct on the calculator. You need to also like check it with your common sense. Okay, so let's take another look at the equation that we're graphing. So we're graphing this equation, f of x equals x squared minus 2x minus 8 over x minus 4, okay? And we know that basically as x gets close to 4, y gets close to 6, so that seems correct based on the points that we plotted, so like kind of based on our table. But it doesn't seem correct in light of the fact that the point x equals 4 is not in the domain of the function, and yet it is on our graph. So something is like slightly wrong with the graph. And the way that we can figure out what's wrong with the graph is by looking at the equation a little bit more in detail. Okay, so if I take this equation of our function, which was x squared minus 2x minus 8 all over x minus 4, well, I could factor the numerator to look at this in a different way, okay? And if I factor this down, I would get x minus 4 and x plus 2 on top all over x minus 4. Okay, so do you see how it's x minus 4 over x minus 4? It seems like we can cancel that. So basically, we can cancel that as long as x doesn't equal to 4. Okay, so I'm going to just write if x is not equal to 4 here, then this is equal to x plus 2. And x plus 2 is the graph of a line or a linear function. So in this way, it makes sense. Okay, so basically what this lets us know is that the graph is linear because this rational function is actually a line, except at x equals 4. So our graph is not completely correct because x equals 4 is not in the graph of the function. So if we're going to make our graph more accurate, what we need to realize is that this point here is not actually on the graph. So there is actually a hole at the point on the graph where it should be 4, 6 is not there. Okay, so when I put the hole there, now my graph has been made more accurate. Okay, so summarizing everything together, we can say that, you know, the question we were asking is what happens when x gets close to 4 to y. So as x gets close to 4 from either direction, so we're coming like this, y gets close to 6, even though the point 4, 6 is not on the graph of the function. In other words, even though x equals 4 is not in the domain of the function. Okay, so we say that the limiting value of f of x as x tends to 4 from the left, so that means as x approaches 4, that would be more like this one from the left. So when x gets close to 4 but less than 4, or on the graph to the left of 4, we see that y approaches 6, but it's a little bit less than 6. Yeah, 5.99 is a little bit less than 6. So we say that the limit is 6, and then we write the limit as x approaches 4 from the left with a little minus sign, meaning that x is close to 4 but less than 4 of f of x equals 6. And the limiting value as x tends to 4 from the right, so similarly, the right side of 4 would be like 4.1, 4.01, stuff like that. The y values are getting closer to 6, but just slightly bigger than 6, and the limit would still equal to 6. Okay, so the left limit is 6, and the right limit is 6, and then we can say that the two-sided limit is also 6. So please note that a two-sided limit exists if and only if both the left and the right limit exist, and they're equal, okay? So we can state that the limit is 6 and the limit is 6, okay? So it's important to note that the limiting value statement above does not depend on the value of f of x at x equals 4 because 4 is not even in the domain of the function. So let's just take a brief step back this is the concept of a limit, but this also shows you how to find a limit 3 different ways. So the first way is make a table of values to the left and to the right of 4 x values, and then plug in the y value and see what happens to them. The next one is to make a graph. Be careful because you have to take the whole into consideration, but looking at the graph, we see that as x gets close to 4, y gets close to 6. Okay, so this would be graphically, the table would be numerically. We could also do it algebraically. Based upon the computation we did in E, we can say that the limit as x approaches 4 of this function, because the limit as x approaches 4 is asking what happens when x gets close to 4 but not equal to 4, so then we can do that cancellation, right? At first, if I try to plug in 4, I have a problem because I would have 0 over 0, which is undefined, but after I do my simplification, because I know that x isn't equal to 4, I can replace that with x plus 2. We can try plugging it in again, and I would just have 4 plus 2, which is 6. So we can also get the answer algebraically. So any of those 3 ways are perfect, and they all give the exact same answer of 6. So even though x can't equal 4, we know that when x is close to 4, y is close to 6.